All right, so for my tip number 2, I said that if you have the integral of x to the n ln of x dx, the integral of x to the n arc sine of ax dx, or the integral of x to the n arc tan of ax dx, you're going to make your u be the complicated part of the integral. Why? Because these terms are actually easier to get the derivatives rather than their anti-derivatives. And in this case now, because it's easier to get these derivatives rather than their anti-derivatives, this antiderivative now seems much easier, right? You just got to use some sort of general power rule. Now, you just got to be careful though, because not all examples will require you to use integration by parts. So here's my 4th example. Let's say I begin with the integral of 1 over x times ln of x raised to the 3rd power dx. In my notes, I said, read it. In my notes, I said that we make our u be ln of x, right? But if you think about it here, if u is actually my ln of x in this example, what is my derivative? 1 over x. Your du is going to be 1 over x dx. Now, if you look at inside your integral closely, you do have 1x dx. Yes, you do. Here's 1 over x, and there's a dx. So here, you just have to use a u substitution, right? So this example is just a simple, now depending on your levels of u sub here, your experience, I'll put a simple u sub. It's not integration by parts, right? So this will give us the integral of 1 over u to the 3rd du. And then you could have just rewrote u as a negative exponent, u to the negative 3rd du, use your power rule, add 1 to the exponent, it's negative 2. So it's u to the negative 2 over negative 2 plus c. And then you rewrite this, right? So your u was ln of x. The negative exponent, you could bring it down into the denominator, right? So it's, if I pull the negative away from the 2 in the denominator out of the fraction, I'm going to have a 1 on the top. Technically, it will be 2 times u squared, or I can say 2 times ln of x squared plus c. Right, so that would have been my answer for example 4, where again, it was a simple u sub because if you make u your ln of x, then its derivative is 1 over x, which is already part of the integral. Okay, so that one, no integration by parts. But now let me show you another example. Let me just see. Are you guys ready? Ready? Okay. So let's see if I can find an example here. I think this example should work. I'm not too sure because I didn't work it out yet in my head. But let's say if I had the integral of ln of 2x over x squared dx. What would be my u in this problem? What's my u? It's going to be the ln of 2x. So your u, based off of our tip, u must be equal to ln of 2x. Now, when you take the derivative of ln of 2x, in the numerator should be the derivative part of 2x divided by exactly 2x, right? So what is the derivative of 2x? 2x? Sorry, no, the derivative of 2x is not 2x, it's just 2. So it's going to be 2 over 2x dx. But you can simplify this, right? 2 over 2 is just 1 over x. So du simplified is 1 over x dx. Now, if you look inside of my integral, we don't have 1 over x. In fact, we actually have 1 over x squared. So can I replace du with, sorry, can I replace x squared dx by du? The answer is no. The answer would be no. Why? Because du is equal to 1 over x dx, not 1 over x squared dx. So here a u sub can't be applied. Okay, so we need to define our antiderivative. That will be our dv. So now my dv is not necessarily going to be x squared, right? It's technically 1 over x squared. So we say it's 1 over x squared dx, but 1 over x squared, you can bring that up into the numerator. No? 1 over x squared is just x to the negative 2 dx. All right, and then from here, you get your antiderivative. So what's the antiderivative of x to the negative 2? That's right, x to the negative 1 by the power rule divided by negative 1. So I'm going to clean that up for you. We know that any term divided by 1 is always going to be that term. But since it's a negative, I'm just going to pull the negative out. Now, in particular, x to the negative 1 was located where? It was located in the numerator, so I can bring it back down into the denominator. So our v is 1 over x dx. Yes, negative 1 over x dx. Yeah, go ahead. What? What do you mean? No, you need integration by parts. I just said it. I said earlier on, when du is equal to 1 over x dx, that is not exactly x squared dx, or 1 over x squared dx, so you can't use this. U sub is not allowed here. Right? Look at your du. It's 1 over x dx, not 1 over x squared dx. No. No. Okay, so I'll show you how it works now. So what we have is u times v. Therefore, I can say negative ln of 2x over x, right? Because ln of 2x times 1 is just ln of 2x, but because there's a negative in front of it, I stick the negative in front, and we're going to divide by x. Then we subtract by the integral of v times vu. So it's, sorry, I got to stop writing this dx part here. All right, so we have v is negative 1 over x multiplied by 1 over x dx. Okay. Now you just combine like terms inside the integral, and then you integrate. Right? What's negative 1 over x times 1 over x? Negative 1 over x squared. Now, in particular, right, when I write out these next two lines, as you mentioned, it's negative 1 over x squared dx, but that negative sign, I can pull it outside of the integral. And if I pull this negative outside, what happens to the two negatives? It turns positive. So we will have negative ln of 2x over x plus the integral of 1 over x squared dx. But didn't we just integrate this piece? Yeah, we did. We did that earlier on when I defined it as my first dv, when I used the integration by parts originally. So we knew that its antiderivative is going to be negative 1 over x. And what do I include, or what do I attach? I just attach a plus c at the end. Okay. So because we already established what's this antiderivative earlier on, I could just say that our next line will be negative ln of 2x over x. Well, the antiderivative was negative 1 over x, so it's minus 1 over x plus c. You could have cleaned this up one additional line. I'm going to zoom out a little bit. You could have said this is negative ln of 2x minus 1 all divided by x, since x was the common denominator, plus c. And ta-da, done. Let me just stop the recording. And then we'll